Welcome, ladies and gentlemen, to my channel. Today, we are looking at an interesting topic in accounting and finance research, and that is moderating variable. Moderating variable are being used in the finance and account research in recent time, and it has become of interest to accounting and finance scholar, and that's why I'm bringing this to you this moment. A moderating effect occurs when a relationship between two variables are influenced by a third variable. This third variable is known as the moderator. As the moderator, the moderator changes the strength, the direction, or nature of the relationship between the independent variable, or that's the predictor variable, and the dependent variable, which is the outcome variable. Simply put, a moderator explains when or for whom a certain effect occur. So basically, a moderating variable is that variable that just causes, a joint influence on the dependent variable. It causes it is jointly influenced. It comes together with the dependent variable to come and influence the dependent variable, and it's expressed in a diagram form as this. As we have here, we have the DPS, which is representing the dividend per share. We have the ROA. The direct relationship between dividend per share and Tobin's Q, which is a firm value, is the straight line that we see. That's the horizontal line from DPS down to Tobin's Q. That is the direct effect, and the equation for that can simply be expressed as in Tobin's Q is equal to beta O plus beta 1 DPS. That the beta 1, which is the coefficient of of dividend per share, beta 0 is the constant of this equation. So, whereas when we talk about the mediating effect, like we have in this diagram, you can see the ROA is coming to join in the relationship between the relationship that dividend per share has on Tobin's Q. So that's why I refer to it as simply a joint effect, because ROA comes together with DPS to come and influence Tobin's Q. And when you are the equation that contains that moderating effect can also be seen in this second equation. That's where you have Tobin's Q equals to beta O, beta 0 plus beta 1 DPS plus beta 2 ROA plus beta 3 DPS times ROA. The last component of that equation is the moderating is the moderating effect. That's the component for the moderating effect. The second the second component is that of the effect of the dividend per share, and the third component is the effect of the ROA, direct effect of ROA on Tobin's Q. And the first component actually represents the constant of the equation when all else is equals to 0. That's the beta 0. So this is basically how moderating effect diagram looks like. So with this understanding, we'll quickly move into Stata. But I've actually prepared a do file commands with which we are going to run the analysis in Stata, and this is basically how the do file looks like. We're going to run the descriptive statistics, which the command is there, some Tobin's Q, DPS, ROA, and the next, the second analysis is the correlation, which is also stated, and from there we'll run the OLX regression without the moderating effect, unless that will give us an idea of the direct effect of this of these variables, that's of DPS and ROA on Tobin's queue. And from there, we'll create the interaction term. This is how to create the interaction term in Stata for when you have to, if you're running the moderating effect. Like we are creating interaction term for dividend per share and ROA, which is dividend per share underscore return on asset, which is equals to dividend, that's DPS times ROA. That's the Stata command we are going to use. And now, once we generate that command, we can then run the OLS regression with the moderating effect. And this is the Stata command that follows. And after we have done that, we'll look. We can also extend the this analysis further by running a panel data. Still using the moderating effect, we're going to run the random effect. This is the Stata command I'm using for the random effect. And the last one there is the fixed effect. In this video, we are not going to interpret, we are not going to run the Ushman test to determine whether fixed effect or random effect is the most appropriate for the model. So that said, we'll move into Stata. My data is already loaded in Stata. So this is my data editor. My data is here. I'm using the consumer goods sector of the Nigerian Stock Exchange. So my data loaded. The only thing that is missing is the interaction term, which I have not created. With the do file, we're going to run the interaction term. The ROA is here. The ROA, the Tobin's queue is here, and you have the dividend per share. That's dividend per share, Tobin's queue, ROA. So we have the three variable in this uploaded consumer goods sector data. So let's go to the command window and let me get the do file. I need to get the do file. I need to get the do file for this. Yes. Yeah. So this is the do file like I showed you in the PowerPoint slide. And we start with once I click on execute, all this analysis will be run by using this do file. Do file is just a short call. It's a macro in Stata that we use in running series of program. It makes the process simple for you. You need to learn how to use do file. So having created, since we have the do file already created, all I need to do is to execute this do file, and we have all our analysis. That's it running at the background. The process is completed. All the analysis done. We have the descriptive statistics. As you can see, that's the first analysis run there. The descriptive. From the descriptive, we move down to the correlation matrix. You can see the correlation between Tobin's queue and dividend per share is 0.6698, and Tobin's queue and ROA is 0.578. That's that for correlation matrix. We have the third analysis there, which is the OLS without the moderating effect. That's the result. We have 160 observation, and the F statistics is highly significant with a value of 93, which shows that the model is highly fit for this analysis. Our R square is 54%, and the adjusted R square is 53%, which also which shows that about 54% of factors that influence Tobin's queue is explained by this our model. This is now the result further explained. The influence of DPS on Tobin's queue is positive. It's positive and highly significant at 0.001%. ROA2 is highly significant at the same level and is positive and is highly significant because the p-value is 0.000. So now at this point, the step 4 is to create the interaction term. The starter code has been executed and the interaction term has been created. So with that, we can run the OLS to be sure that your interaction term is created. You can always check the data editor. That should be the last thing. That's the interaction term here. DPS underscore ROA. So that interaction term was successfully created. So, and the regression with moderating effect has been, also run successfully. Total observation is 160. The value of the F statistic is 61.79. The p-value for it is highly significant at 0.001%. The R square is 54%, and the adjusted R square is 53%, which is not too different from what we had in the earlier regression. So the interpretation of the dependent variable now, the DPS, the coefficient is positive and is significant at a 5% level. Positive and significant at 5% level. ROA on Tobin's Q is also positive and highly significant at a 1% level. So the interaction term, that's a DPS underscore ROA. The interaction effect here is positive, but it is not significant because the p-value is greater than 0.05%. So for this, we can say while the DPS has a significant and positive influence on the Tobin's Q, and so also is a ROA having significant and positive influence on Tobin Q. The moderating effect is not is positive but not significant. So it's not the interaction is not material enough for us to make any statistical inference. That there is indeed a moderating effect. So depends on how your hypothesis is stated, you can then accept or reject it accordingly. So this is an extension of the moderating effect using panel data. This is the command. The command for the panel data is here. ST regress Tobin's Q, DPS, ROA, and the interaction time. This is the random effect. And you can see the results without much ado. Under this under panel data, you will discover that dividend per share is not significant because the p value is far above the 0.05 level. ROA remains significant under the panel data. That's under the random effect. And the influence of the interaction term 2 is also not significant under the random effect. But let's see what happened under the fixed effect. Under the fixed effect, you discover that dividend per share becomes significant at 5% level because the p-value is 0.01. ROA remain highly significant at 0.01% level. The interaction term, interestingly, too, becomes highly significant under the panel data. But the question remains: which model will you go for? Are you going to use the fixed effect or the random effect? To determine that, you actually need to run the Ushman test, and that will help you determine which effect matter, whether it is the fixed effect that is appropriate for your model or whether it is the random effect. But for this video, we are going to stop at this point. We are not going to extend it further. If you have any question or you want further inquiry on this, you can drop your comment or reach out to me on this. Thank you very much for your time, for stopping by. And do not forget to like and subscribe like and subscribe so that you can always receive a notification when the next